Let's look at the reflection of a point in a plane. The example says the plane capital Pi has equation minus 2x plus y plus z equals 5. The point P has coordinates 1, 0, 3. The point Q is the reflection of the point P in the plane. Find the coordinates of point Q. And here is a side view of the plane with the point P and its reflection, point Q. Now we start by rewriting the equation of the plane in the following form. So we have x, y, and z multiplied by minus 2, 1, 1 equals to 5. And so the equation of the plane has been written in the form r dot n equals to k, where r is x, y, z, n is a normal vector to the plane, and k is a constant. And so a normal vector to the plane is given by minus 2, 1, 1, which we can mark on this diagram. And so we have the normal vector going in a perpendicular direction to the plane. We'll mark this on as minus 2, 1, 1. Now if we connect the points P and Q, we get the line P to Q. We can see that the line P to Q is parallel to the normal vector to the plane, which is minus 2, 1, 1. Now the general equation of a line in vector form is given by r equals a plus lambda b, where a is a point on the line and b is the direction vector of the line and lambda is a scalar parameter. And so for the line PQ, we can work out the equation of the line since we have a point on the line given by P, and since we have the direction vector of the line given by the normal vector to the plane, because the normal vector is parallel to the line PQ. And so we have R equals 1, 0, 3, since 1, 0, 3 is a point on the line PQ, plus lambda times minus 2, 1, 1. Since the direction vector of PQ is parallel to the normal to the plane. Now if we let M be the midpoint of P and Q, we can see we marked it on the diagram here, and so we can represent M, since it's on the line PQ, as 1 minus 2 lambda, lambda, and 3 plus lambda. And we get this by multiplying minus 2, 1, 1 with lambda, and then adding that result to 1, 0, 3. Now since M is on the plane pi and the equation of the plane is given by x, y, z dotted with minus 2, 1, 1 equals 5, we can replace x, y, and z with 1 minus 2 lambda, lambda, and 3 plus lambda. And so if we do that, we get 1 minus 2 lambda, lambda, 3 plus lambda, dotted with minus 2, 1, 1, and this equals to 5. And so if we use the dot product, we have 1 minus 2 lambda multiplied by minus 2, which gives us minus 2 plus 4 lambda. And then we have lambda times 1, which is plus lambda. And then we have 3 plus lambda times 1, which is plus 3 plus lambda. And this equals to 5. And so collecting like terms, 4 lambda plus lambda gives us 6 lambda. Minus 2 plus 3 gives us 1. And then this equals to 5. And so if we take away 1 from both sides, we get 6 lambda equals to 4. And so lambda equals to 4 over 6, which can be simplified to 2 over 3. And so this tells us that if we start from P on the line PQ and lambda equals to 2 over 3, we end up at M. And so we can mark this on our diagram as when lambda equals 2 over 3, we get from P to M. Now since M is the midpoint of P and Q, and to get from P to Q, lambda would need to equal to double the amount here. In other words, 2 times 2 over 3, which gives us 4 over 3. And we can see this on the diagram here. Now to get the coordinates of Q, make lambda equal to 4 over 3 in the equation of the line PQ given by R equals 1, 0, 3 plus lambda times minus 2, 1, 1. So if we substitute lambda equals 4 over 3, we end up with the coordinates of Q as being R equals 1, 0, 3 plus 4 over 3 times minus 2, 1, 1. And so multiplying this out, we get R equals 1, 0, 3 plus, now 4 over 3 times minus 2 gives us minus 8 over 3. 4 over 3 times 1 gives us 4 over 3. And 4 over 3 times 1 gives us 4 over 3. So we have R equals, now 1 plus minus 8 over 3 gives us minus 5 over 3. 0 plus 4 over 3 gives us 4 over 3. and 3 plus 4 over 3 gives us 13 over 3. And so the coordinates of Q is given by minus 5 over 3, 4 over 3, and 13 over 3.